Greetings, mathematicians. Today we're going to work on another word problem and a two-step problem. And we're also going to look at some multiplication equations using multiplying by 12s. So I was fooling around with my baseball cards because the problem today is about collecting baseball cards. And I have some of my favorite players. When I was a new teacher in New York City and Peter was still in graduate school, we would go to the Mets games a lot. And Gary Carter was one of my favorite players. He was a catcher. And I also loved Darryl Strawberry so much. And another big favorite was the pitcher Dwight Gooden. Then later, my mother became very interested in the Braves. So we always watched the Braves together, and I love Chipper Jones, love Tom Glavine, and I have a few others in here. And you can see I have an array of the cards. 9 cards will fit on my paper, 3 times 3. So this is a good introduction to our problem of the day. Here it goes. Michelle collects baseball cards and puts them in a binder filled with pages that hold 9 cards each. Her goal is to collect 270 cards. Right now, she has filled 11 pages in her book. How many more cards does she need to meet her goal? All right, well, what's this problem asking? If I was going to put this in my own words, I'd say it's about a kid who's collecting cards and she wants to get 270 and she already has 11 pages in her book filled up. And then our detailed dragon says, underline the important info, please. So to me, each page has 9 cards. That seems important. Emery agrees. She wants 270 is her goal. So that's what she wants to end up with. She already has 11 pages. And the problem is how many more? So U2, of course, orders us to write an equation. U2's in our mind saying that you must write an equation. Okay, so there's more than one equation. We talked about this yesterday. We could have, if I was going to do one, I'd probably start with 9 times 11, because I know she has 11 pages and there's 9. And then she wants to get some more, so I'll put C for cards. And once she gets more, she'll have 270. So if I solve the problem, I can use my equation. 99 plus C equals 270. So I have to subtract the inverse. 270 minus 99. Well, I know 270 minus 100 is 170, but I'm going to use the regrouping way we do it. Borrowing from the tens, 10 take away 9 is 1, 6 take away 9, can't do it, 16 take away 9 is 71. So she needs 71 more cards. We want to write that. Now let's try a different equation and see if it comes out how we want it to be. Now let's say we started this way. She wants 270 and we want to take away what she already has and see how much more she needs. And we can tell that's going to work because it's pretty much like what we did up here. 270 take away 99 equals C 71 equals C. So remember, we talked yesterday about being flexible with the equations. There's lots of different equations that would work for this. And another one, we're not going to solve it, but if you had 270 and you took away what's missing, you should have what she has. So 3 different equations. It's all going to give you the same answer, 71 cards. Now, I want to talk a little bit about multiplying with 12s today. Oh, I know. I'm going to use my card paper. So let's stack up my baseball cards. Let me put Dwight there at the top. He was great when he was young. Okay, so pen. You should be taking notes while we're doing this. A lot of you, the other day when we were doing math, we compared 2 ways to multiply by 11s. Zach's way and John's way. Some of you liked Zach's way because it was loops and groups. Some people liked John's way because you said it was very organized and you could see the 30 plus 3. So we're going to use John's way today with our base 10. You know, when we make a base 10, we can just use a rectangle for a 10 and a little square for a 1 unit. So we got 10, 11, 12. So we're going to call that 1 times 12 equals 12. Let's do a few more. Now, let's say I add another 10, 11, 12. Now I have 2 times 12. And that's 10, 20, 21, 22, 23, 24. We also know we could just do 12 plus 12 is 24. And let's move on and go to 3 times 12. We're going to add another 10, 11, 12. 3 times 12. You know, if you would 24 plus 12 more, you'd have 36. You can also see it very clearly here, 10, 20, 30, 32, 34, 36. Let's do a few more. 4 times 12. Hope you're doing this along with me. 4 times 12. Now we know the 4s are double, so we could double 24 plus 24. We could add another 12 to 36, or we could see very clearly it's 4 times 10 is 40. 4 times 2 is 8. We got 48. Nice. Let's do 5 times 12. Not making these very carefully, but that's okay. 5 times 12 is going to be 48 and 12 more. You can see it's also 5 times 10 is 50. And 5 times 2 is 10. So 50 plus 10 is 60. All right, I'm just in for another one now. Just can't stop. Six times 12 is going to be 60 plus 12 more. It's going to be 72. And we see we have 7 10s. And 2 times 7 is 14. No, 1, 2, 4, 6, 8, 10, 12. Sorry, guys. 6 times 12. I got ahead of myself. I started thinking of 7 times 12. And speaking of 7 times 12, let's see if we could use a different way to do it. What if we broke the numbers up into 7 times 10, just like we're kind of breaking them up here into tens and ones, and added that to 7 times 2, and you can kind of picture the tens on one side and the ones on the other. And that would be 70 plus 14. That's going to be 84. And when you get into the larger numbers and the 2-digit multiplication, you can remember that you can break up these numbers. So let's say you had a little quiz one day and someone asked you what 8 times 12 is, and you wouldn't say, oh, I haven't memorized my 12s yet, I have no idea. No, you know how to do it. You go 8 times 10. Let's break that up into 8 times 10. And we can do the plus it, add it to the 8 times 2. And we get 80 times 2 is 16, 96. So let's add these two equations, 7 times 12 and 8 times 12. 84, and 8 times 12 equals 96. And we will add our base 10 block models. It's just a nice, so there's all these different ways to do it, and I love being flexible with math. Okay. We're going to end there. You're going to do some pages in your yellow book. And thanks for coming to my math video today. Emery, thanks you too. Thanks, guys.